Hello everybody, today I'll be going over an array sorting algorithm called the Heapsort algorithm. In these next few minutes I will attempt to explain what a heap is, how the Heapsort algorithm works, and why you might want to use it. So in order to understand how the Heapsort algorithm works, first we need to understand what a heap is. Basically, a heap is a data structure called a binary tree. A binary tree data structure has data points arranged in nodes. Every node can have up to 2 child nodes. This is why it is called a binary tree. Also, every node will have a parent node except for the root node, which is the node at the top of the binary tree. In order for a binary tree to be considered a heap, it must be complete. To be complete is to say that every level on the binary tree will be completely filled except for possibly the bottom layer if there are not enough data points to fill it. A heap must also satisfy the heap order property, which means that every node must be equal or greater in value to the ones beneath it. Now that we understand what a heap is, we are able to unpack and understand how the heap sort algorithm works. Let's say we have an array length 5 and we want to use the heap sort algorithm to sort it from least to greatest. First we must treat the array as though it is arranged in a complete binary tree. From here we need to take our binary tree and convert it into a heap. In order to do this we need to start at the very last parent node, or the last node to have children, heapify this subtree, and work our way backwards, heapifying each subtree as we go. For those of you looking to use this algorithm in your code, the last parent node can be determined by taking the size of the array, dividing it by 2, and then subtracting 1. Each time a part of the tree is heapified, we must recursively go back and reheapify all subtrees beneath it. For those of you who do not know what recursion is basically calling the method within itself, usually with modified arguments. Now our array has been heapified. From here you will notice that the very first element in the array is also the very greatest element in the array. This is because the root of the heap is always placed at the front of the array. This means that we can now swap the first element, which is the root of the heap, with the very last element in the array, and then lock that place down so we don't have to deal with it anymore, meaning that we have now got the greatest element at the very back. We can now reheap the reduced array and then reswap the root of the new reduced heap with the last element in the reduced array. We then repeat this process until we have all of the elements in the array sorted in order from least to greatest. Now, I'm sure many of you may be wondering why we would go through such a complicated process to do what could be easily done just using a temporary variable. However, there are some practical uses for more advanced sorting algorithms like heap sort. For example, if you wanted to sort an array with a length of 100,000, heap sort would be a far more efficient way to do that than using 2 for loops iterating over the entirety of the array. Well, I hope you found this video informative, and if you have any questions or feedback, I am more than willing to help, and thank you for watching.